Let's start discussion. On last video, we have seen that how we are finding the time complexity in the better way to find the time complexity using and also taken an example of prime number. So let's discuss on the particular video for the better time complexity program. We found out that we are using the calculation up to root n. So we are going to find why we are using up to n. So let's start with the definition. What is a prime number? So a number a number that is only divisible by 1 and itself. Okay, so any number that is divisible by 1 and itself, we are going to call them as a prime number. So let's take some example to know what is prime number. Let's say n is prime. So I have an example question. If is n is a prime number. Okay, let's check. Okay, let's check for 1. So see, for 1 we have one number that can divide 1. So that's why 1 is not a prime number. Now let's take an example of 2. So for 2, yes, 1 and 2, only 1 and 2 can divide 2. So it is a prime number. Again, now check for 3. So for 3, 1 and 3 only. So again, it is a prime number. For 4, however, for 4, we have 1, 2, and 4. So it is not a prime number. For 5, so it will be 1 and 5 only. So it is a prime number. Hope we are clear with the concept of the prime number. So we have like now we have a question like how we are going to determine in how it is a prime number or not. So we can see that we are checking from 2 to the like we know that it will be any number will be divided by 1 and that number itself. So we should check from 2 to that particular number. We don't need to check for that particular number. We will be checking one less than that particular number. So what we can write is uh, for for let's take any I less than 2, then I will go up to n minus 1. Okay, and if we get any I in between 2 to n minus 1, if divide n, so if we get any such I in between 2 to n minus 1, then we will call that n is not prime. Okay, however, I have a question like do we need to check till n minus 1? Because let's say if it is number is divisible by itself, so it will we will have another number 1. So once we divide by the number, it will be give that like we'll have a one more number is 1. So let's see if we can check up to n by 2. Should it be sufficient? Yes, it should be sufficient because like after n by 2, it will be like a repetition. So as we should check uh, till n by 2, so we can say that n by 2 is sufficient. Okay, but can we make can we do better? So always we should ask a question if we can do better. Okay, So how can we do better? So if we have a number b, if n is divisible by a, then we will have a different number b. That means a into b should give me n, and this a and b is called as cofactor. Okay. So any number that is, if we can divide any number by a, it should give me b, and if we multiply this a and b, we are going to get that particular number. So let's take a example now. Let's take an example of 36. Okay, 36. For 36, what we'll going to get? First, if we divide with 1, we will get 36. Then if we divide with 2, we are going to get 18. If we divide with 3, we are going to get 12. If we divide 4, we are going to get 9. If we divide by 6, we are going to get 6, and it's a special case. Now, if we divide by 9, it is going to give us 4. It again, if we divide by 12, it's going to give me 3. If we divide by 12, we are getting 3 here. And if we okay, 12 we already find that. If we divide by 18, we are going to get 2. Okay, let me erase this. Okay, if we divide by 18, we are going to get 2, and then if we divide by 36, we are going to get 1. So these are the cofactor of 36. But if we observe carefully, we can see that these cofactor are repeating. Okay, here 4 and 9, then we are getting 9 and 4. Okay, then we have 3 and 12. We have 12 and 3. Okay, the only difference is we are the sequence is difference. Okay, 3 and 4 here like 12 and 12 and 8, 18 and 12, 1 and 36, 36 and 1. Okay, so here we can find out that it's is a little bit repeating such that. Okay, so let's say let's take the example of 36, and if we have a special case as that a is equal to b, that means a square is equal to n. That means n is a perfect square, so we can say that a equal to root over of n. So now we have two conditions. So once a might be less than b and b might be less than a. So let's take if a less than b, it implies that a will be less than root over n and b will be greater than root over n. From the above example, we can easily find out if a is less than n, and so b is less than b is greater than root over n. Same for the opposite case. If b is less than a, then a will be greater than root over n and b should be less than root over n. So if we put this thing in a number line, so we can find out, let's say this is the number line and this is uh this is 36 root over n. This is root over n. For our case it's 6. Let's say this is 9, this is 12, this is 18, this is 36. This is 9, this is 12, this is 18, this is 36. So here we will have 4, we will have 3, we will have 2, and we will be having 1. Okay, so uh, we can see that if one factor is greater than root over n, another is less than 4, less than n. So we should not need to check all the way to n by 2. For us, n by 2 is this much. Okay, but till if we check till uh, root over of n, we should be covering all the factor. Okay, so if we didn't get any number till root over n, we are not going to get any number beyond that. Okay, so so we can check. That's why we should check till root over of n. So that's why on the previous video we have checked till root over of n, because checking till n by 2 or n, it's highly time consuming and computer will take good amount of time. Okay, so hope you guys have understood why we took till root over of n. If you have any question, you can comment in the video, and we will be uploading such video in SD Hub every day. So thanks for watching. Have a great day. Bye.